When it comes to solving area problems, you always want to first draw a diagram. So if it's a rectangle, make sure that the opposite sides are the same, but the length and the width are different. So this is a rectangle. If it's a square, make sure all the side lengths are the same, and you can use a symbol like one little tick mark to make sure that you know that the sides are the same. You can also label it. And with rectangles, we usually use L for length and W for width. Now, use all the given information in the problem, and then you're going to apply the properties of a square or a rectangle in order to solve the quadratic equation to find the unknown. Make sure to identify the variables. For example, for a square, you'll write S is equal to side length. And by identifying the variable and indicating what it represents, when you are trying to solve the problem at the end, you will know what numbers to plug in to find the value of a certain dimension that you're looking for. In the prior slide, we solved this problem about a square, and now I'm going to explain how to solve it. So the problem says a square is altered so that one dimension is increased by 5 inches and the other dimension is decreased by 2 inches. So from here, from the first sentence, we know that it's a square, meaning all my side lengths are the same. So now one dimension is increased by 5 inches. So 1 is increased by 5, so we'll add 5 to one of the lengths. And the other dimension is decreased by 2. So the question is, what does decreased by mean? Decreased by means it gets smaller, so it'll be S minus 2. So now we know our two dimensions. Our one dimension, dimension 1, is S plus 5, and dimension 2 is S minus 2. Notice our sides are different now, the lengths, so we know this is no longer a square, but it's becoming a rectangle. Now, if the area of the resulting rectangle, see the word rectangle comes out, indicating that the side lengths are different, is 98 inches, what is the area of the original square? So from this rectangle, we know this new rectangle now is 98 inches. We're going to multiply the length and the width because area of a rectangle is length times width. So area equals S plus 5, because that's dimension 1, times S minus 2, which is dimension 2. And to show you, S minus 2 is this length right here, and S plus 5 is this length right here when we change the square. The area of the rectangle is 98. So we know the area is now 98, so the new equation is S plus 5 times S minus 2. We can rewrite this to help us out. Now to solve, since the equation does not equal to 0, we have to FOIL. So we get S squared minus 2S plus 5S minus 10 equals 98. Then what we're going to do next is we're going to subtract 98 from each side. And we'll get S squared. We could simplify negative 2S plus 5S, which is 3S, minus 108 equals 0. If we do the X method, 12 times 9 is 108. So negative 108. And we know B has to equal 3. So we know it's negative 12, positive 12 times negative 9. That equals 108. And if we combine it, it's 3. So from our X method, we know now that the equation is S plus 12 times S minus 9 equals 0. Now we want to find the value for S. So since S plus 12 and S minus 9 equals 0, S plus 12 equals 0, S minus 9 equals 0, minus 12 on each side, S can equal negative 12, and S can equal 9. Now from our original equation, when we're looking at square, we see that S is the side length. So now the question that you have to ask yourself is, can the side length be negative 12? Or can the side length be 9? Well, if you said, yes, side length can be 9, you are correct. But if you say, yes, the side length can be negative 12, then you are incorrect because the side length cannot be a negative value. So your final answer is that S can only be represented by 9 inches. So to find the original area, 9 times 9 is 81 inches squared. So your answer would be 81 inches squared. If you got it right, good job.